So now that you've got a chance to have a bird's eye view of streams, and we talked a bit about sequential versus parallel streams and some of the pros and cons of streams in terms of parallelism hazards, let's summarize some of the benefits of streams. Now, some of this stuff is kind of premature because you really don't get the sense of some of these things till you've had a chance to play around with it. But I want you to kind of get a feeling for why this is a win, and then we'll dive into the details, having a good, warm, fuzzy feeling that this is a good thing to do. So let's talk about the benefits of a stream. So there's a number of benefits to programs in terms of execution, and perhaps more importantly to us as programmers, people writing code and maybe even more to the point, reading code. That's some of the benefits there. To make this discussion a little bit more concrete, we're going to use a running example, which you can get here at this URL. This is called Image Stream Gang. And Image Stream Gang is actually a variant of some of your programming assignments, although it's not really the same in a lot of ways, but it's a variant. It basically takes a list of URLs and downloads those URLs if they're not already downloaded, and then it goes ahead and downloads the ones that are not yet downloaded, applies a bunch of filters to transform the images, and then it collects the results into a list which can then be displayed in a nice way on either a command line interface or an Android app or some other type of GUI. So we're going to use this to kind of illustrate the benefits of streams. So one nice thing about streams is they're concise and readable, once you understand the syntax, of course, and the semantics. If you don't understand the syntax and semantics, it's somewhat daunting, but it's very easy to learn. And the reason it's concise and readable is because streams is the so-called declarative paradigm. Remember, there's two primary types of paradigms in computer design and implementation. One is imperative, where you tell the computer what to do. You say, do this, followed by that. And a good old loop statement and an if-else statement, those are good examples of imperative programming constructs to manage control flow. Conversely, the streams model is declarative. So whereas imperative focuses on how things work step by step, because you tell the computer what to do, the declarative model says what to do, and you leave it up more to the underlying software platform, in this case the streams framework, to figure out the how. Now, of course, there is a bit of how, like these behaviors are some how, but a lot of the details are pushed into the underlying part. So when I think of declarative versus imperative, when I think about what the benefit is, I always think of an iceberg where a lot of the implementation details are lurking under the surface. And I'm thinking of a friendly, happy iceberg, not like the iceberg that sank the Titanic, right? That was a different kind of iceberg. But in this idea, the implementation stuff is hidden, and you just focus on what you want to have done. So that's one reason why it's a win. And in this particular case, for the image stream gang example, you can see here that we actually have no Java control flow operations shown in the main structure of the program. So the way you read this is you say, take a list of URLs, convert it into a stream, get rid of stuff that has already been processed before, don't redo stuff we've already cached. From everything that's left over, download it, and then apply a bunch of filters and collect it into a list. That doesn't say anything about the how, really. It just says, do this, and in these high-level steps. The other kind of cool thing about this is you can read this program linearly from top to bottom. Whereas if you looked at this written in the more traditional way with a loop and an if statement, you'd have to kind of play runtime program. You'd have to say, okay, for each element in this thing, if this is the case, then do that, else do this. You'd have to kind of play compiler, play runtime, which is going to be a little bit more complicated. So it makes it easier to see at a glance what's happening once you know how to read this particular syntax and know the semantics. Another benefit of streams is it's flexible and composable. You can connect functions together automatically and very quickly and very easily and in a very canonicalized way. It always looks the same because we're using the fluent interface pattern. So in particular, the output from filter is passed as the input to map. The output from map is passed as the input to flat map. The output from flat map is passed as the input to collect, and so on. So it's a little bit like connecting things together in Lego or something like that. Or more to the point, if you ever programmed in Lego-like programming abstractions like Scratch or Scratch Junior, those are examples of things you kind of connect together visually. Similar kind of idea. Another benefit, and this, of course, is what's really motivating the whole course, is simplified scalability. So we can go from a sequential stream, which is this view, to a parallel stream literally by going, well, not literally. We have to do a few more things. But it's not much more stuff. We use parallel stream here, and we do a little bit of other fancy footwork here we'll talk about later. And then we can get massive speed up, in this case pretty much linear, close to linear speed up, without having to write any multi-threaded code. So we don't have to spawn any threads. We don't have to apply any synchronizers. We just say parallel stream and a few other little things, and boom, the abstraction maps onto the underlying processing engine, which in this case is the common fork join pool. And we've talked about that before, so that's just a pool of threads used to process all these behaviors in parallel. So much simplified, you can get scalability without having to manage all this gobbledygook yourself, which is nice. And of course, the other nice thing is that the framework, in this case the fork join framework, maps the abstractions at the Java worker thread level onto the underlying processing cores. And that works very efficiently and scalably on modern multi-core processors, which, as you all know, have an increasing number of cores because, of course, Moore's law is leading to more transistors that don't run much faster, but run by scaling through parallel processing. So that's just a quick summary of some of the benefits of streams. And you'll get firsthand experience playing around with all this stuff in the class, so hopefully it'll become much more intuitive.